Well, I think I'll get going, folks. As I posted to let you know, I'll probably just be going over some homework questions from the homework. I guess this was on Thursday, Wednesday, Thursday homework. And I might do some extra ones as well from the same questions just to make sure that you see a whole bunch of different examples of the types of questions that you can expect. I'd like to end the lesson today on one of the word problems and maybe give you just a few of those word problems in homework tonight to make sure you're seeing the styles of questions to expect there as well. So as always, if you have any questions, just post them in chat. I'll try to keep an eye on that, and we'll get started. So in all of these questions, and you may need to remind me of this, you were supposed to first list the restrictions and then try to simplify. Okay, so if we take a look at 5a here, we have y minus 2 over 2 minus y. And we want to first list our restriction before we start to simplify. So looking at that y value, what y value can we not have because it would make the denominator equal to 0. So as I've mentioned before, this is kind of like finding zeros in quadratics, but it's stuff you can't have equal to 0 instead. So y can't be equal to 2. I think that one's pretty easy. And we've talked about these scenarios where the top and the bottom look very, very similar, except that the bottom is kind of like reversed, right? It's got the opposite signs as to what the top ones would be. So actually, in this case, what I would probably do is I would factor a -1 out of the top and not out of the bottom, simply because I don't want to have a negative sign at the bottom of the fraction. I mean, it'll cancel out anyway, but I think this is what I would prefer to do. So we're factoring out a -1, which makes the y negative and the 2 positive. And then we do have something that's matching at the top and bottom. So the 2 minus y and the 2 minus y will cancel out at that point. And we are left with -1 as our final answer with that restriction. So a pretty easy one to start us off. B is almost the exact same thing. Let's take a look at D together, and I'm just going to do D here if you don't mind. So we've got 6 minus 10w over 15w minus 9. Once again, we'd want to list our restriction before we begin. So now this is one of those cases where there is a coefficient in front of the w in the denominator. So as I've shown you before, you take the constant term, switch its sign, so it'll become positive 9 over 15, and w can't be equal to that. My not equal sign there is terrible, sorry. Okay. And maybe just for the sake of practicing some fraction rules here, if you do 15 times 9 over 15 minus 9, 15 and 15 cancel, you end up with 9 minus 9, which would be your 0, which we don't want in this case. So it definitely does work. Okay. And now we want to see if we can factor anything out from both the top and the bottom. At the top, we can factor out a 2 to leave 3 minus... you know what, though? Looking ahead, I can also see that the w term is second here with a minus sign in front of it in the numerator. And the w term is the first thing in the denominator. So I think instead of just factoring out a 2, I'm going to factor out a -2 in this case. And that'll make the 10w become positive. It'll be a 5w now. And the 6 will become negative, which will actually be a 3 now because we factored out a 2 as well. And at the bottom, I am going to factor out a 3. And that's going to give a 5w minus 3. And again, we have a scenario where everything is now factored, so everything is now multiplying and dividing as the main operations, top and bottom, so we can cancel out those two terms, or those two factors, sorry. And we end up with -2/3 as our final answer for that one. So, good little warm-up questions here for this homework. I am going to assume that that was fairly well understood and just move on at this point. Now you'll notice in question number 6, the homework questions that I'd given you actually went a little bit beyond what I had shown in class. I had mentioned in class that type 2 trinomials were going to start showing up. And I put some in the homework just to, challenge you a little bit, see if you could remember how to do them. So we'll start with letter E. Now E is a type 1 trinomial scenario, so we have x squared minus 10x plus 24 all divided by x squared minus 12x plus 36. We cannot list our restrictions until we've factored because we don't know what they actually are. So this is a question as to how quickly can you factor. So I'm not going to build my trees anymore. Actually, maybe I'll do it for this first one just because we haven't seen it in a couple of days. So 24 is the top of my tree. Negative 10 is the end of my tree. I need two numbers that multiply to 24 and add to negative 10. 12 and 2 will do that as long as 12 is negative. Okay. Two numbers that multiply to 36 for the denominator and add to negative 12. That would be negative 6 and negative 6. So I don't have to, for type 1 trinomials, I'm trying to get you to move away from having to write everything down and just be able to do it mentally. So we're going to have our two brackets at the top, and at the bottom it's a perfect square trinomial, so we're going to have our brackets squared at the bottom. So we have x minus 12, x plus 2. I'm just going to pause here, make sure I'm not making any mistakes. It is a Monday morning, so I'm prone to make mistakes those days more than any. And I believe the bottom one is going to be x minus 6 squared. I believe that's all correct. Now, did I make a mistake at the top? Oh, you're absolutely right. See? See? Negative 12 times 2 gives negative 24. So I went too fast there. Thank you very much, chat, for fixing that issue. So it would be negative 6 and negative 4, right? I was kind of hesitating. I don't know if you noticed, because as soon as I got to here and saw that nothing would cancel with the top, I was like, But I, for some reason, didn't see that I had made that mistake. Okay, so this will be negative 6 and negative 4. So thank you very much again. All right, so stating our restrictions, what value can x not be equal to? X cannot be equal to 6 as our restriction. And now, because we do have things that cancel at the top and the bottom, now only one of the x minus 6's is going to cancel from the bottom. Remember that x minus 6 squared means there's two brackets there. It's x minus 6 times x minus 6. So you're just canceling out one of the brackets. And therefore, we end up with x minus 4 over x minus 6. And I believe that is the correct final answer. Let me know if it isn't. Okay, let's take a look at H. So we have one type 2 trinomial in the top of H and one type 1 trinomial on the bottom. So this is the first time I'm reviewing a type 2 trinomial with you, so I am going to do the full thing here. So we need two numbers that multiply to 2 times minus 1. So the first thing you do with a type 2 trinomial is you multiply the first number times the last number, so that would be negative 2. And we need two numbers that multiply to negative 2 and add to the middle number, which is negative 1. And those two numbers would be negative 2 and positive 1 in this case. So if I continue off to the side here, that means my 2t squared minus t minus 1 is going to become two brackets. And the first thing you do is you look at the first term in the trinomial, 2t squared, and you've got to come up with two things from FOIL, okay, the first part of FOIL, which is f, that multiply 2t squared. Well, the only two things that multiply to 2 are 2 and 1, and the t squared would be t and t, so I need 2t and t as my two terms inside of the brackets there for the f part of FOIL. And here comes the most difficult part of my way of factoring. So I'm going to repeat the way this works again. The O and I of FOIL as answers to that multiplication have -2 and 1. Okay? So the way you have to ask yourself this question is 2t times what in the O part of FOIL, 2t times what equals one of those two numbers that we got when we broke it down. Well, I can't make 2 multiply to a number to 1 as an answer unless the number is a decimal. We don't want decimals. So 2t times what equals -2. That would be -1. And then t times what is the other one. So we've used the -2 now. The only one that's left is the 1. So 1 times what equals 1? It would be +1. And that is the way that I factor type 2 trinomials. It's kind of a combination of trial and error with decomposition so that we don't actually have to do trial and error. But you have to remember that the O and the I of FOIL have these two numbers as their answers. And then everything works out really well. As long as I didn't make any mistakes. So I'm gonna keep saying that caveat because, as I mentioned earlier, Mondays are bad for that. So 2t plus 1 and t minus 1, I believe, are the two factors for that trinomial. Now for the bottom trinomial, it is a type 1 trinomial, so I just need to find the two numbers that multiply to 2 and add to -3, which would be -2 and -1. So t minus 2, t minus 1. I'm gonna fix that bracket there. And now I can list my restrictions. Okay, so my two restrictions come from the denominator. The t cannot be equal to neither 1 or 2. So that's how we would list that. And now we can cancel out our repeating brackets from the top and the bottom, which would be that one. And our final answer is 2t plus 1 over t minus 2. So I'll just stop there for a second, ask if there's any questions, make sure I didn't make any mistakes before we move on. Okay, so let's do one more, and I'm going to do L. I'm going to skip J. I'm going to do L because it's one of those cases where we have two variables. So we have 2m squared minus mn minus n squared, all divided by 4m squared minus 4mn minus 3n squared. So we know that our brackets are going to have m's and n's in them. I'm assuming these are going to be factorable, so I'm going to just set everything up. This may not be the case always, but because we're in this section, I'm assuming they're all going to be factorable. So we're going to have an m and an n in each bracket. We just need to figure out what the coefficients for all of those are going to be. So if we look at the top one, 2 times -1 is -2. I need two numbers that multiply to -2 and add to -1, which again would be -2 and 1. Is that the same as the one we just did? Yes, it is. If you look at the 2, -1, and -1, it's the exact same one as h, which is interesting. So we already know what that one's going to look like even if we didn't know. So it's a 2 and a 1 and a 1 and a -1. So I think I did that right. For the bottom one, we have 4 times -3, which is -12. The sum is -4. Now, one thing you should always check too, folks, is there anything common factorable before we start? Nothing can be common factored out of the top nor the bottom. So that's why we have to do the trinomial factoring right away. So we need two numbers that multiply to negative 12 and add to negative 4. Now I believe the combination is going to be 6 and 2, and I believe the 6 is going to be negative. So we've got to look at our 4, and I'm going to do this off to the side just to show you what's going on. So I know it's going to be m and n in both of these brackets, but the FOIL part has to multiply to the 4m squared. So what are my two options? I have 4 times 1, or I have 2 times 2 that gives me 4. So the issue is the O then has to multiply to either the negative 6 or the 2. So if I put a 4 here, can 4 times something give negative 6? No. Can 4 times something give 2? No, not unless they're decimals, and we don't want that. So that means the 4 and 1 are the wrong option. So we have to use 2 and 2. 2 times what equals negative 6? That would be negative 3. And 2 times what equals positive 2? That would be positive 1, so just a plus will do. And now I factored out that bottom trinomial as well. So this is going to allow me now to find my restrictions. So going back up, usually when you write your restrictions, now it doesn't actually matter. You can actually write them right next to this, and maybe I will. You can write them right next to this fraction if you want, but a lot of teachers actually ask you to write the restrictions right back up to the top, but it technically doesn't matter. So, so what are my two restrictions? Well, the coefficient here, okay, actually this one's a little bit tougher because of the two letters. So we've got 2m plus n can't be equal to 0. So, whoops. So that means that 2m can't be equal to negative n. And there's a couple of ways that we can write this. If we're trying to find what m's restriction is, we would isolate to get m by itself, which would be negative n over 2. So m, I'm going to run out of room here. M, okay, let me erase this part here. M can't be equal to negative n over 2. And if we do the same type of thing for the second bracket, m can't be equal to, it'll be 3n over 2. And I chose to do the m's simply because they were the first letter in the bracket alphabetically. Okay, you could have isolated the n in the equations instead and listed the two restrictions for n, but they would have just been written in functions of m. So either way is fine. And there's, I don't know how they did it in the back of the book, but that's the way I would be expecting you to do it. Unless there's something weird in the back of the book that I'm not aware of, I believe that should be somewhat what they wrote as the restrictions for that. And once we have our restrictions done, those two cancel. And hoping that everything I did was correct here, that should be the final answer with the restrictions. Any questions about that one? Seeing no questions, unless something pops up, I will continue. So number 8, again, it always stated to state the restrictions before you start to factor. So if we look at C, we've got y squared plus 1 over y squared minus 1. Our restriction would be that y squared can't be equal to 1. I'm going to write that off to the side here. That means that y can't be equal to the square root of 1. And that would be plus or minus. Okay, so our restriction would be y can't be equal to the plus or minus of the square root of 1, which is just 1, actually. Don't even need the square root anymore. Okay, so if 1 was replaced for y, we'd have y squared, which would be 1 minus 1. If y would be replaced by negative 1, we'd have negative 1 squared, which would also be minus 1, which would also give us 0. So those are the two restrictions. Now I'd want to try to factor this. Oh, and I just realized something. I kind of did this in a slightly different way than maybe some people would consider acceptable. There is another way to see those restrictions. And in fact, if you notice that the denominator here is a difference of squares, that's what you would get. And that would give you the exact same restrictions as the ones I found using this method instead. So I've been harping on everybody factoring, and I chose to do this one without factoring for the restrictions, but it's because it can be done this way as well, because it's just isolating with a square root. Now, can anything be simplified? It does say simplify if possible. So that's suggesting that it may not be simplifiable, if that's a word. And in fact, you cannot simplify here. There is nothing that exactly matches the top to the bottom, so you cannot simplify, and that means that is our final answer. Which technically means you probably could have just left it like this, but just to show that it is factorable and we get the same zeros, or the same restriction, sorry, let's leave it like that. So for E, we have t squared minus s squared over s plus t all squared. So, what would our restriction be? Well, our restriction would be that s cannot equal negative t. Okay, now how did I figure that out? If I take s plus t can't equal 0 and isolate s, the t comes over to the other side and becomes a negative t. Okay? So the only thing that would make the denominator 0 is if we substituted negative t in for s. Now, can you see at the top that that is a difference of squares? Sorry. Which would give us that. Now, is t plus s the same thing as s plus t? So because t plus s is, I think that is commutativity as well, even though it's not multiplication. S plus t and t plus s are exactly the same thing. So you can actually cancel those out. Like so. And we end up with t minus s over s plus t. So I hope everything's still okay in chat. I haven't seen any questions or comments. Everybody still hearing me? Okay, perfect. No questions. If we go back and look at some of the other ones in 8 that I haven't done yet, I hope you can see that they're actually pretty easy, especially D. Now F, I think I'm going to skip F. I'll just talk about the numerator in F. As soon as you see an x cubed, you've got to be a little worried. And just to maybe plant a little bit of a cautionary tale in your ear here, folks. Yes, I have seen some scenarios where you actually have to do long division in one of these questions to be able to factor it before you can find your restrictions or simplify. Okay, so we've actually seen examples in the IB prep course of long division when it comes to cubic relationships. That does sometimes crop into these too. Okay, not usually in grade 11 though. But in this case, instead of doing long division, can you see that all 3 of these are factorable, common factorable by an x? And then you're just back to doing regular trinomial factoring if it works. 2 numbers that multiply to 3 and add to -2 does work. Does it work? No, it doesn't work. Because it would only be 3 and 1. And you can't make one of them negative to get the -2. So actually, that trinomial isn't even factorable. Which might be the first time it's happened in the homework today. Okay? So that x squared minus 2x plus 3 isn't factorable. So you'd end up with your x at the end here. And then you'd have to check your trinomial at the bottom and see if it's factorable. And it is at least common factorable. Oh, okay, I see what's going to happen here. So when we take out that 2, then we're going to have the exact same trinomial as the top, and we'll actually be able to cancel out that trinomial instead of just a binomial. So it will end up be simplifiable because of the common factoring nature of this question. So if you haven't tried that one, or if you didn't get it right, I've just given you some advice as to how to proceed. So give it a shot, see what you can do, and hopefully you'll be okay. And if you have any questions, let me know in email, okay? Okay, question 5. I think we're getting towards the end here. So question 5, I had only given you 2 to do. Now, for A, once you set your restriction, which is x can't be equal to 4, I'm hoping you can see that you can just cancel those 2 out and that the 3 and the 6 can actually simplify to 1/2. Okay, so I think doing that one orally is good enough. For B, however, we need to talk about B because I quickly introduced that to you, and I am going to give you some more division type questions probably today in homework. At first glance, it kind of looks like there may not be any restrictions in this question because 5 and 10 are whole numbers, and therefore there are no restrictions on 5 and 10. However, as soon as we multiply by the reciprocal to actually be able to deal with a division with a fraction, then the y becomes a variable in the denominator, and we have to state that as a restriction. Once you're done that, any top value, because it's a multiplication, can be canceled out with any bottom value. That'll leave a 2 and a 1 behind. 10 divided by 5 is 2. The m plus 2 and the y minus 1, though, do not simplify. So we just end up with 2m plus 2 over y minus 1 as our final answer for that one. So dividing by a fraction, be very careful. As soon as you flip it, you have to also check to see if there's another restriction that was created. And if you look at some of the other examples in number 5, there are going to be cases like in D here, where you're going to have a restriction of x can't equal 2. Actually, it came from this one as well. But then when you flip it upside down, you'll also have a restriction of x can't be equal to -1. All right? So just that's the only thing you got to be careful with divisions of fractions. Okay, we will move on. So this is a simplify with a trinomial scenario and a multiplication. So I'm just going to try to fit that in right here. Actually, can we try to factor it as we go here? So two numbers that multiply to 12 and add to 7. So again, how quickly can you do that? Okay, so it's 4 and 3. Does not matter what order you put those into a type 1 trinomial. I like to put the biggest number first, but it doesn't actually matter. Then we're going to do the bottom one. So two numbers that multiply to 4 and add to 4. Well, that's pretty easy. It's 2 and 2, and this is a perfect square trinomial, so it's a plus 2 squared. Times two numbers that multiply to -6 and add to -1. Now this is where you have to be very careful. Any combination of 6, 5, and 1 in trinomial factoring, you always have to stop and ask yourself and make sure you're doing it right. So I'm just going to write it down here to make sure that I'm doing this correctly. Not that it helped in the past, but hopefully it'll help here. So what a lot of students will do is like, well, I guess there's only one choice here actually. Now that I think about it, it's not as bad. If there's had been a 5 down here, that's a little bit scarier because there's often, you know, two possibilities, like 2 and 3 will add to 5 and 6 and 1 can also add to 5. But having a 1 down here, it's not as bad as I thought it was. I just got scared when I saw the, actually it's a -1, my mistake. I just got scared when I saw the -6 because I always do. So in this case, it's going to be -3 and 2, right? Yeah, that's the only possibility. So we have a minus 3 and a plus 2. And then a squared minus 9 is a difference of squares, which you have to be able to recognize as quickly as you can. Oops, sorry about that. And that would be our factored version of b. Now we can state our restrictions. So we don't have to worry about the division because there is no division between them. It's a multiplication here. Our restrictions, and I'm just going to write them here. A can't be equal to. So if I want to list them in order, it would be -3, -2, and 3. So the -3 came from a plus 3. The -2 came from a plus 2, and the positive 3 came from a minus 3. So now we want to simplify. Any top thing can cancel out with any bottom thing. So that means this can cancel out with this. This can cancel out with this. This can cancel out with this. Again, the only reason we can do that is because the main operations are multiplications and divisions. I know I keep harping on that, but it's because I've had mistakes be made by students many, many times about this stuff. Okay, and I believe those are the only two brackets left, so that would be our final simplification. So imagine going from this in some sort of equation scenario that you're trying to solve some sort of bigger problem and ending up with this as your simplified version. Like, how much easier would it be to work with this version, right? So the beauty of simplification. Are there any questions? Not seeing any questions. Let's move on to the last thing I'd like to do today. And that is to start looking at some of these word problem type scenarios that they're going to give you in this section. And like I said, I'm probably going to give you a few others in homework to try, just to make sure you read them and see the types of questions that are expected of you. So on a soccer pitch, the goal area or the goal box is inside the penalty area or penalty box and forms part of it. Now, I do not know anything about soccer, so I'm only referring to that picture. And I don't think the goal section is actually important at all. It's only the white box here, which has got 2 measurements on either side of it, and the overall area here, which has got 2 measurements on either side of it. Okay. The dimensions of the goal box and the penalty box are represented, like I said. Write an expression that represents the area of the goal box. So because this is a rectangle, not a lot of difficulty here. We're expecting you to remember the formula for the area of a rectangle, which we've done multiple times. So it would be 10⁹ x times x over 3. We'd want to simplify that, at least multiply through together, okay? Nothing cancels here. The x's are numerators. The 10 can't simplify with either the 9 or the 3. So we end up with 10x squared over 27 as the area for part A. So I'm going to call that area 1. You'll see why in a second. Then it says write an expression to represent the area of the penalty box. So I'm going to call that area 2. Again, it's still length times width. And we've got 22 over 9x times x, which is going to give us 22x squared over 9. Nothing simplifies there again. Question C is where this question becomes actually more interesting, and you actually see a lot of questions like C in both math and physics. Yeah, I won't tell. Well, just to give you an example, in physics, we learn about the gravitational forces between 2 objects. And one question that comes up a lot in physics is, if I increase the mass of one of the objects as to twice its mass it was before, what would be the change in the force? And that question and this question are actually very, very similar in their natures. So you're going to see this type of thing happen a lot, where it says determine how many times as great the area of the penalty box is to the area of the goal box. So you can clearly see that the area of the penalty box is much bigger than the area of the goal box. They're asking you, can you find out how much, like by what factor it's bigger? And I've seen this kind of question mess students up as to how do you calculate that? Do you subtract? Do you divide? What do you do to figure out how much bigger, how many times as great one area is to the other one? And that is a division. You're going to take the bigger area, which is area 2, and you're going to divide it by area 1, which is why I wanted to write the subscripts of 2 and 1, so we can keep those 2 areas separate, okay? So the area of 2 is 22x squared divided by 9, and the area of 1 is 10x squared divided by 27. Now, I would strongly recommend that even though I wrote this as a fraction, knowing that both of these things were going to be fractions dividing each other, I would have actually strongly recommended that you write it like this. And the simple reason is to try to remind you that you have to flip and multiply. Now, there are no restrictions at the moment, okay? But as soon as I do this, then we have the restriction that x can't be equal to 0. Okay? Now, something interesting happens here. There are quite a few things that will cancel. The x squared will actually cancel with the x squared. The 27 and the 9 simplify to 3 over 1. And the 22 and 10 will simplify because both of them are divisible by 2, so it'll be 11 and 5. Now, if you can keep track of all of those numbers, so 11 and 3 are now multiplying at the top, so that's 33, and 1 and 5 are now multiplying at the bottom, which is just 5, that is our final answer. Now, you could write that as a decimal. I'm not going to pull up my calculator. Somebody, if you want to do that, you can. But it's 33/5 bigger than the box, right? Sorry, the penalty box is 33/5 bigger than the goal box. Now, there's an interesting question, D. Does the fact that x represents 16.5 meters affect your answer to part C? Explain. Well, if x is equal to 16.5, does that matter? Will that change the proportion in size? And the answer is no, because there's no x left. So it doesn't actually matter what the size of the soccer field is. If it's built proportionally correctly, that should always be the difference. Sorry, not the difference, but the ratio of sizes of the two. And that's the style of word problem that you can expect in this section. So in your homework, I'm probably going to be giving you some questions like that, similar to that style. And as you were doing your homework from the last few days, you might have seen a few. I think we actually discussed a few the other day too, but I'd like you to actually practice them tonight. So that is going to be it for today's lesson. Technically not a lesson, more of a homework correction session, but I think it's important to go through those homework questions sometimes. So I'm going to say bye for the recording.